instead of CSTR plug flow reactor, what if I use batch reactor? Then what if I design the batch reactor? How large volume of batch reactor is required? What will be the space time? Right? So let's understand that, right? So let's get started. So in the third part, we are using the batch reactor. In similar way, we are keeping all the operating parameters to be constant, identically the same. We are using the same first order reaction kinetics with the given rate law has minus RA is equal to KCA, right? Where the K is equal to 0.0002 second inverse, right? So how large volume of batch reactor is required in order to achieve the 90% conversion? How much time will it require in order to achieve the 90% conversion, right? So we'll understand and calculate that, right? So let's say the first step is to write the performance equation of the batch reactor, right? The performance equation of the batch reactors is indicated by T is equal to CA naught integration of 0 to XA dXA upon minus RA, okay? So we will try to modify the performance equation, right, based on the given data. So let's say minus RA can be written as KCA. So T is equal to CA naught integration of 0 to XA dXA upon KCA, right? Now similar way here, what form of CA we need to utilize, right? So again, don't get confused. We are trying to derive the performance equation, right? We are trying to derive the performance equation. We are trying to formulate the performance equation. We are trying to derive the reaction rate. So remember that whenever we are trying to derive the reaction rate, the performance equation, we are trying to formulate the performance equation, we'll always use the second form of the CA, right? So we'll always use the second form of the CA, which is the fundamental relationship, and is always correct, okay? And is always correct, okay? And the second form of CA is defined, defines the conversion, right? The CA also defines the concentration of reactants at any point of the batch reactor, okay? So due to those reasons, we will use the second form of CA in order to modify the performance equation of the batch reactor. I hope you understood, right? So we'll use the second form of the CA, okay? So let's say T is equal to CA naught divided by K. Now why K? CA naught divided by K, because K is constant, right? We have the value of K has 0.0002 second inverse. Due to those reasons, we can take K out of the integral, right? We can take K out of the integral. So CA naught divided by K, integration of 0 to XA dXA upon